Okay, Assalamualaikum warahmatullahi wabarakatuh. First, I would like to introduce myself first. Okay, my name is Muhammad Alif Daniel bin Ahmad Sofian and I am with my group member Ahmad Muhib bin Rushdan from group L01B01. Okay, today we will present our project for the subject BEB 25303 Microprocessor and Embedded System under the guidance of Dr. Ismail bin Adam entitled Water Level Controller. Okay, next slide. Yeah, I will start this presentation by presenting the introduction of this project. The main purpose of this project was created is because we want to introduce one of the early warning system in issuing warnings when floods are near or have already occurred. For everyone knowledge, floods are a common natural disaster in Malaysia. Every time a flood occurs, a lot of damage and loss will happen to anyone affected. Early warning system are an important component of a disaster risk management strategy. Okay, next. Okay, we refer to the problem statement section of this project. Flood are a common natural disaster in Malaysia. Traditionally, when the flood occurs, it will be too late for the resident to save their goods. One of the main factors is there is no alarm or warning system to warn the residential about the increasing of water level. Also, the timing of the water to release to the river are important to prevent the flood. If the rains are too heavy, the water will be increasing drastically. So the water should release early to prevent an overflow. Now, with the water level controller, it can give a signal to controller at the dam to release the water to the river if the water rising when flash flood occurs. It also can help an early warning to the surrounding. Uh, sorry, it also can have an early warning to the surrounding resident in the event of a water rise in their area. Next. Okay. Okay. The main objective of this project is to design and develop a water level controller with a warning alarm system to inform nearby residents about rising water level in the river. And the objective of this project is also divided into two, namely where the resident will be able to know the reading of the increasing water level, and we be able to design the design the warning alarm by a certain level of water level. Next. Okay, this is a brief overview of our project in a block diagram. Okay, as we can see there, we use ultrasonic sensor as our project input. In operation, the sensor is mounted over the water. To determine the distance of the water, is transmit a sound pulse that reflects from the surface of the water and measure the time it takes for the echo to return and send the information to the STM32 processor to process the data. After that, the data will be shown in the output section, which consists of three components, namely I2C LCD, LED indicator, and buzzer. Okay, that's it from me. I leave it to my group members to explain further. Thank you.
Right, thank you to Aleph. Now I will explain the flow chart. So the flow is when it start, the LCD will display water level, and L is for liter. Row 2, it will print a condition. And next, in a teratem, it will display a water level alert. And then TO will time out and it will delay 500 millisecond. Then it will go to 1, which T1 time out, ultrasonic get the data. Then if the distance is below 20 cm, it will go to yes. And then flag 1 and case 1 will trigger. And then it will go to teratem. It will display distance equal to how many distance in cm. And then the LCD will print at row 1 it will print distance, and at row 2 it will print condition. Next, if the distance is not under 20 cm, it will go to the second condition, which is a distance between 20 cm to 90 cm. If the distance between 20 to 90 cm, it will trigger flag 2 and case 2. It will also print distance, and then the LCD will will print distance at row 1 and row 2 will display a condition. Next, if the distance not 20 to 90 cm, it will print flag 3, case 3, and also at term it will print distance in cm, and then LCD row 1 it will print distance, and at row 2 it will print condition. So this is our list of components that we use. Number 1 is Nucleo 64 STM32F401 as a microcontroller board with STM32F401 on board, completed with ST-Link2 and serial line converter on USART 2. The quantity is 1. Then LED indicator for indication if water level rising in certain level. We will use 4. Then a buzzer to alarm if the water level in critical level. 1. Ultrasonic sensor, an electronic device that measures the distance of target object by emitting ultrasonic sound wave and convert the reflected sound into an electrical signal with 1. And next, 16 times 2 I2C LCD we use to display 16 character line, and there are 2 such line. The LCD will show the water level. Next is the functionality. First, ultrasonic will send wave to detect water level. Then STM32 will process the data. Next, the output will display at I2C. Next, indicator will on if the water level at alert level. Then a buzzer and indicator light will on when the water at emergency level. So next is our schematic diagram. This is how we connect to STM32. So the ultrasonic VCC to VCC and ground to ground. Triggered at ultrasonic will connect to PC3 at STM. And echo at the ultrasonic will connect to PC0 at STM. Next is I2C LCD. As usual, VCC to VCC and ground to ground. SDA to PB7 and SCL to PB6. Then we use PA8, PB10, PB4 and PB5 for our LED. So next is our video project. Row 1 LCD will show the distance. Row 2 will print all good if the distance above 90 cm. Next is when the distance is between 20 cm to 90 cm, the LED will toggle and print alert. When the distance is below 20 cm, the LED will toggle and buzzer will on. The display will print flag warning. Then if there is no water level increasing, it will back to standard mode and print all good. That's all from us. Thank you.